Alright guys, welcome back. This is video number 2 and we're going to start where we left off. So on this slide I'm going to take you through my logic, and then on the next slide I already have the proof written down, and so I'm going to pause on that so you have time to copy it down. So here's my logic for this problem. We are given that this entire outside shape is a parallelogram. So because I know that's true, I know that both pairs of opposite sides are congruent. So I'm just going to mark that for myself. I also know, because the outside shape is a parallelogram, that both pairs of opposite angles are congruent. Same with this pair as well. Now, the reason I wrote that out is if you look at this triangle and this triangle, they're currently congruent because of angle, side, angle, angle, side, angle. So if this triangle is congruent to this one, that means that I know that this segment would have to be congruent to this segment. And I also know, because these two triangles are congruent, that this segment here is congruent to this segment here, which means I could take the big red segment, subtract the purple segment, and get this blue segment by subtraction property, take this big red segment, subtract the purple segment, have this blue segment by subtraction property. So it looks like now you could say that both pairs of opposite sides of the quadrilateral inside are congruent, so this has to be a parallelogram. So that was me talking about it overall, but I did write it out formally for you as well, so give you time to process it. So I'm going to flip to this, I'm going to scroll this down, and my proof ended up being 10 steps. So this is the time that if you would like to pause it here, I would like you to copy it down, look back at the picture, and process what's going on. So please pause now. So guys, after you sat and processed it, if you do have more questions about this in class, I'd be happy to answer it for you. I hope that you are taking the time to see if it makes sense to you rather than just copying it down. Okay? The next proof, I want to do the same thing. I want to talk about overall what's going on, and then I already have the proof done for time-saving purposes. So I'm given that CAR is isosceles with base CR. So that means that I know that these two legs are congruent. So while I'm at it, before I look at the rest of the givens, that means I know that these two angles are congruent because of if sides and angles. So that's nice. I'm also given that AC, this segment, is congruent to BK. So this and this are equal, and these two are equal too. Maybe we can use the transitive property. The problem also says that angle C and angle K are congruent. So it looks like I'm going to be using the transitive property because my goal is to prove that this is a parallelogram, and I have to use one of those 5 ways to do so. So I'm just going to write down a few quick notes. I know that because of the isosceles, that angle C and angle R are congruent. It gives me that angle C and angle K are congruent. So by the transitive property, I know that R and K are congruent. I also know with segments that it gives me that AC is congruent to BK as a given. Because of the isosceles triangle, I proved that AC is congruent to AR. So that, again, if I'm using the transitive property, I know that BK and AR must be congruent. So these two segments are congruent, these two angles are congruent, and if you look carefully, the two green angles are corresponding angles. They're congruent, they touch these two purple lines, and they're along the same transversal. So you could prove that because these two angles are corresponding and congruent, these two lines are parallel as well. So you could use the reason if one pair of lines are both parallel and congruent, then it's a parallelogram. So this one had transitive property written all over it. So that was my overall again. We have proven that this is a parallelogram. But again, I'm going to switch over to this slide, and I'm going to scroll down, and I'm going to give you time to copy down my work. Now notice one little thing. When you're proving a parallelogram at the end, notice I wrote of a quad here. If one pair of opposite sides of a quadrilateral, a four-sided figure, are parallel, then it has to be a parallelogram. Okay? So let me give you some time again to copy this down, to take your time, process it, and please let me know if you have more questions in class tomorrow. So please pause now. All right, on to our last two ones. This is practice with coordinate proofs. And as soon as you have something on a coordinate plane, remember that a couple things could come in handy. Specifically, slope is going to be so important today. You also could use the distance formula, because my goal is to prove, are these quadrilaterals parallelograms, rectangles, a rhombus, or a square, based on what I'm given, based on the coordinates I'm given, what's the best name for the quadrilateral. And I would say that slope is usually the way I'm going to be doing it, because I feel like it's a lot faster than the distance formula. I'm sure you agree with me that slope is usually faster. So I'm going to be focusing on that the most with these two proofs. And we're going to be using coordinate proofs again, mainly to prove rectangles, rhombi, or squares. Parallelograms, we're going to do the formal stuff we were just doing. So for this first problem, the first thing I want to do is just plot all these points. Negative 10, 4, so point A. Point B is negative 2, 10. Point C is 4, 2. And point D is negative 4, negative 4. So I'm going to connect all these dots. And you can't always go by what the picture looks like. You have to prove it, because as you've known from this year, you can never assume from a diagram. So before we use slopes to prove what this is, I wrote some things on the next slide that I want to go over with you. If you want to prove a parallelogram, what you could do is just prove using slope that both pairs of opposite sides are parallel. And if these slopes are the same and these slopes are the same, you have it. If you want to prove a rectangle, you would first have to prove that both pairs of opposite sides are parallel, because a rectangle is a type of parallelogram. But what makes a rectangle different is that you have right angles all the way around. So if you could prove that both pairs of opposite sides are parallel and that your adjacent sides are perpendicular, meaning one slope is like 2/3 and the other one's negative 3/2, then you know it's a rectangle. If you wanted to prove a square instead of a rectangle, the way that squares and rectangles differ in terms of slope is that the square's diagonals are perpendicular also. And so for a square, you'd have to prove opposite pairs of sides are parallel, that the adjacent sides are perpendicular, and that the diagonals are perpendicular also. A rhombus is a type of parallelogram as well as these two, so you'd prove both pairs of opposite sides parallel, but a rhombus, like a square, has diagonals that are perpendicular. So if you proved both pairs of opposite sides are parallel and diagonals are perpendicular, you would have a rhombus. Now, a rhombus does not hit right angles on adjacent sides, so that would not be something you have to prove. Feel free to, again, pause here if you would like to copy this down. I put this here as a reference for you that I hope is helpful. So pause if you'd like. But I'm going to go back to this problem and see if I can focus on slopes. Specifically, I'm going to focus on slopes by counting. Remember, slope is really just rise over run. So if I wanted to find the slope of this green line, it looks like I'm going up 1, 2, 3, 4, 5, 6 units, and I'm going over 1, 2, 3, 4, 5, 6, 7, 8 units. So my slope rise over run would be positive 3/4. If I look at the opposite side here, it looks like I'm going down 6 units and to the left 8 units. So that rise over run is also a positive 3/4. So this is a good start. If I look at these slopes, looks like I am going down from 4 to negative 4. Looks like I'm going down 8 units, and then I'm going to the right 6 units. So this slope here would be rise over run, or negative 4/3. And this slope, rise over run, would be up 8 units to the left 6 units. So this slope, rise over run, is also -4/3. So I know that this shape is at least a parallelogram because I have both pairs of opposite sides, 3/4, 3/4, -4, -4/3, having the same slope. Now, something that's awesome though is that this slope is -4/3 and this slope is +3/4. +3/4, -4/3. So these slopes are opposite reciprocal, which means that I know that all of these angles have to be right. So I know that this not only is a parallelogram, it could either be a rectangle or a square. How do I tell if it's a rectangle or a square? Well, if I draw my diagonals in, a square, the diagonals are perpendicular. So let's check the slopes of AC and BD. So point A is -10,4. Point C is 4,2. So if I find the slope the old-fashioned way, 2 minus 4 over 4 plus 10, that would be -214 or -1/7. If I find the slope of BD, I'd be using -210, and I would be using -4, -4. So if I found the slope this way, it'd be -4 minus 10 over -4 plus 2. -14 over -2 is +7. Yes, these slopes are opposite reciprocals, which means these diagonals are perpendicular. So the best name for this quadrilateral has to be a square, because I proved that both pairs of opposite sides are parallel, adjacent sides are perpendicular, and the diagonals are perpendicular also. This next one. What I'd like you to do is get ahead of me a little bit. I'd like you to plot the points, try to find the slopes of the opposite sides, and I'll come back with my work for that so far. So please pause now. All right, so to come back to this problem with you, what I found out was that these two lines both did have a slope of 1, because when I went rise over run, I got 5/5, so these two slopes were both 1. The two little blue triangles I drew, I got both of those slopes to be -1/7. So I knew that this shape at least is a parallelogram because both pairs of opposite sides are parallel. Now, 1 and -1/7, 1 and -1/7 are not opposite reciprocal. So I knew that this cannot be a rectangle or a square. So I'm between a parallelogram and a rhombus. And the only difference between a parallelogram and a rhombus, if I switch over here for a minute, is that a rhombus, the diagonals are perpendicular, and the parallelogram, they're not. So if I go back to this picture, if I drew in the diagonals, if I drew this diagonal and this one, and if I can prove that these diagonals are perpendicular, I know it has to be a rhombus. So I need to find the slope of JL and KM. So here again, I'm going to pause, and I would like you to find the slope of JL and KM and determine if you think it's a parallelogram or a rhombus. I will come back in a little bit with my work. So please pause now. All right, guys, so to come back with you, my slope of JL using the slope formula was a +1/3. My slope of KM was -6/2 or -3. These two slopes are opposite reciprocals, which means that these two diagonals do indeed hit in a perpendicular fashion. So because this quadrilateral has opposite sides parallel, both pairs, and the diagonals are perpendicular, the best name for this shape is a rhombus. Feel free to go back and watch any of this material again. If you didn't get a chance before, I would definitely consider copying down this information all based on slope. So because I think slope is the fastest way, that's usually how I teach it. We can talk about distance formula and other things in class tomorrow, but I, again, would highly suggest slopes are usually the best way. All right, guys, so feel free to come in with questions tomorrow. Thank you for sticking with me during these videos, and I will see you then. Bye.